Hello. Okay, I think we can start our class today. Okay, where is it? Okay, so in previous week, I already introduced to you about the normal filter, right? Normal filter and median filter. Okay. This week, I will introduce to you about one very important filter methods. We call this is the Gaussian filtering, Gaussian filter. And what is it? Gaussian filter is kind of the filter. It's also smooth the image, and it's a very effective for removing the noise. The noise have the Gaussian form. So what is Gaussian? Let's imagine the Gaussian distribution. I think that all of you already heard about this. The Gaussian distribution like a bell like this, right? Like bell like this. Okay, like bell like this. And if we change it to the image, and it will have some kind like this image. And in this image, you can see that surround is very dark, but in the between, right, in the center, right, at the center is very bright. So this the Gaussian filter it will how to say if in your let's say in your wait a moment, where is it? Okay, so if in your image, right, they have some something like the something noise, something like noise, something like this, something like this. Example, in the image, if the pixel is very dark, is some kind dark. Example, they are 2 pixel, they are nearby each other. Example, the pixel have the intensity, example 100, and one pixel have the intensity, example 102, right, 106 or something like that. And if they are nearby, if you apply the Gaussian filter, the darker will become the dark one will become darker, and the bright one will become brighter. Yeah, this is the function of the Gaussian filter, right? And let's imagine this Gaussian filter is often the prefix, the pre-filter for some algorithm. Example like egg detection, or some identification. Example, this is the example. This is the straight line, right? And if the image here something like that, if near the straight line here, there are often some example. Let me check the some picture, another picture. I think this is very better. This one. Okay, so example here. We want to detect the the x, the x here, the x here, the x here, something like this, right? And if we zoom in here, and we have the picture like this, So here you can see that there are very many intensity near the pixel, inside the pixel, right? But we just want to find the edge like this, in here, as here, as here, as here, as here. So the Gaussian filter, they will have that if the pixel here, you can see that it is something brighter than the right hand side, right? Brighter than the right hand side. If you apply the Gaussian filter, it will become brighter, and this one will become darker. So when you apply this, we apply this filter, so we will have the very, how to say, very significant value different here. Example, initial value is about, you example, this is about 100. This one is very dark. Example, this is 200. Example, something like that, right? Something. Oh, sorry. This dark, right? Dark is about example 50. This one is about 150 or something like that, right? When you apply the Gaussian filter, this will bigger. Example 200, and this one reduce about example 30, right? So based on this value, we can find the edge here, the straight line here. So this is one of the function of the Gaussian filter. Okay, yeah. So this is the Gaussian filter is often the pre-filter for some algorithm, right? Okay, and what we have to remember in the Gaussian filter is this function. And in this function, we have some variable. The first one is sigma here. The sigma is the degree of smoothing. Right? That means if it is bigger, example 150 and 50, right? If it is big, it is very big, this will increase bigger, and this will reduce bigger, something like that, right? So sigma here is the degree of smoothing. Okay, and the next one is x and y here. So x and y here is related to this table. So example, this is the mask kernel 3x3. Every filter they have the kernel, right? Every filter they have the kernel or mask, right? So example, the kernel we have 3x3. So at the center it will be 0 and 0. So please remember. So here this is x is 0, right? And y is 0, right? And if we have a sigma here, we have a sigma, example sigma equal to 1, example sigma equal to 1, so something like that. So if we have a sigma equal to 1, x becomes to 0, y becomes 0, so we have the value here, right? We have the value here, and then this one also similar, right? Just replace -1 into x, replace 0 into y, and then you have the value of the mass. Okay, so example, okay, I will give you the specific example of how to define the mass here. Okay. Okay, wait a moment. Okay, let's have a look at the example. Let's have a look at the example here. Okay, so okay, example. We have a picture, right? And the question A asks you to apply the Gaussian filter on this picture using kernel 5 multiply 5. Okay, so the first thing is we have to generate the kernel, right? So let's see how to generate the kernel. Okay, as I said before, right? If we have the kernel or mass, right, at the center will be 0 and 0. Okay, 0 and 0, and then the left column is -1, and then next one is -2. Okay, so based on the index here, right? And okay, and the sigma here we apply, we have the number sigma equal to 1, so we replace sigma here, and then x and y here, and then we have this table, okay, and then we have this table. So do you have any questions on this one? Because this one is very important for you to apply the Gaussian filter. The first thing is to generate the Gaussian kernel. Okay, so we the next one. Okay, so this is the phi and phi, right? Phi and phi. So just replace sigma x and y into the table here, and then we have the kernel here. And one important thing here is, as you can see here, it is the center, right? Center, and this is similar, right? Similar. So this, the matrix here is symmetric. Okay, so that means the Gaussian kernel is symmetric. Okay, so when you apply the convolution or correlation, it is similar. Okay, and then the next one is how to do it. So because we apply the kernel 5.5, right? 5 and 5, so we batting to here, batting the original matrix, right? And then we apply the kernel here. Okay, and here, right? The kernel is here, right? It's here. We apply on here. So we apply, where is it? Is it? Okay. And then if we apply here, what happened? Okay, so here is 0 0, right? So this is 1 will multiply 0.159, right? So because this is here, right? And then the next one is 2, right? Multiply 0.097, right? And then the remaining is similar, and then you will have the value here. Okay, and then you will have the value here, and then do similar another column and rows. You will have the final result is here. Where the final result is here. Okay, and then we will check the result with the Opencv library. Okay, and in the Opencv library we have the function we call, this is the Gaussian blur here. Okay, the Gaussian blur, and the function is, we are inside the function, you just provide the source, right, the destination, the size of the kernel, right, the kernel, and this is the sigma, right, and this is the default 0 and 0. Okay, and then you will have the result. Okay, if you don't want to use the Gaussian blur function here, which function you can do? You can use the filter 2D, right? The filter 2D. right? Filter 2D. The kernel, you have to define by yourself, right? Right. Okay. So apply this one. Apply this one. Okay. And let's see the result. Let's see the result. Okay. This one, let me copy paste the value here, and then we compare. Okay. Okay, let's see. Okay. Okay. The first one is Gaussian filter. We use the filter 2D function. Filter 2D function. And then we compare with the manual, right? By hand, right? We do by hand. And here you can see that it is identical. 100% similar. Okay. 100% similar. Okay. But when we use the Gaussian filter function, it can have some error, small error, just small error. Example here, right? 2.47 here, 2.428, right? Right. But if we do round it, right? Round it. So 2.4, right? Or 2, you round it and then become 2, right? 6.1 and 6.01 it becomes 6, right? So when you round the result, when you use the Gaussian filter, it will be identical, similar with the manual. Okay. So please pay attention here, right? When you use the Gaussian filter. So in the exercise, I will ask you to do two functions, filter 2D and Gaussian function to compare. Okay. So up to this step, so do you have any questions on the Gaussian filter here? Do you have any questions? Okay, no, right? Yeah. So we go to the next one. Besides, I want to say that I already upload the exercise, the group exercise for you, the new group exercise for you. So you can go to the e-learning and download it, right? And then compare with the lecture note, right? And if you have the question, you can ask me. Okay, so this is the Gaussian filter. Okay. Okay. And this one also just some example, short example. Right. If you replace the matrix by the image here, the position is similar, identical. Example, you can use and you do the Gaussian filter, and then you can have some picture like this. Okay. This just one. Okay, and another one is also very important. We call this is the Sobel filter. Sobel filter. Okay, and what is the Sobel filter? Sobel filter is the first derivative of the pixel. What does it mean, first derivative? So in the physical meaning, what is the derivative? Can anyone tell me? What is the physical meaning of derivative? Derivative is đạo hàm. What does it mean in physical meaning? Okay, the derivative is the difference or the changing of the last and then of the last and the next, right? Of the past and the future, right? Of the past and the future. Okay, so example here, this is the equation of the Sobel filter, the first derivative, right? Okay, so up to this step, I think that you just accept the equation. Okay, just accept the equation. Later, maybe next week, I will explain to you more clearly about why the Sobel filter, the kernel is this one. The kernel is this one. Okay, so now just accept the kernel. Okay, so in the Sobel filter, we have two masks. The first mask here and the second mask here. Okay, first mask, the second mask. So we will apply this mask on the picture one by one. First is this one, and then second is this one. So we will have the something like the Sobel filter. And what is the result? The result is okay. The first is we have the function. The function is the Opencv. We can call this is the Sobel, and the Sobel, yeah. And this is the index dx and dy here. Okay, if you want to apply mx, you just set this one equal to 1 and this one equal to 0. Okay, and my, we want to apply my, right? The kernel my on the y direction. You just, this one is 0 and this one equal to 1 again, right? Yeah. Okay, so example, I give you this one. This picture. So let's do the Sobel x and y, and then use the Opencv function to check the result, right? Okay, so let's do the example. So let's see. Okay, so we have the kernel 3 by 3, right? 3 by 3. And if we do for the x direction, right? So this is the kernel for x direction. Okay, x direction. Okay, and then we just apply this one on this one, right? First batting, right? Remember batting, because we want to calculate the result at the position 1 here. Okay, position 1 here. Okay, and one thing I want to mention that if in the exercise I don't say anything about the position of entry point, so just let the default of the entry point position is at the center. Okay. So in here I didn't say anything about the entry point, so we just let the default entry point at the center. So here we calculate this one, right? Apply this one on here, right? And then we will have the result here. We have the result here. So what the result tell you? What does the result tell you? Because we do the batting here, right? We do the batting here. So the result say that, right? At this one, right? At this one, there is a chance. Very big, right? And from here to here is also very big, right? So this one will be the x. Yes. Here is similar. Positive and minus will be the x. Okay. Yeah. Okay. Similar in the my kernel. So what is the result? Just apply the Sobel kernel for the y direction, and apply on this one. So what happened? Here, right? Just apply, and then you have the result here. And then from here you can see that, right, on the y direction, right? So this is the x, right? So from 0 to 25, and then here, right? Here, right? Very big amount, right? Very big amount of the number. Here example similar, right? So you have here, okay? Okay, so that's the some example, right? So in the exercise, I have 3 matrix, right? So each group will have their own matrix, okay, to apply the Sobel filter. And this is the programming. This is the programming. And here, this is the previous image, right? And then I apply the Sobel filter algorithm or the filter 2D. They are similar. They are similar. So you will have the results or something like this. Okay. So this is similar to your manual calculations. So be careful. Okay. So if the manual and the programming, they have different results. So I think that you are doing wrong calculation. Okay. So any question on the Sobel filter up to this step? Okay. Next one. Here, example here, right? Example here. You will have very clear information, right? And if you apply for the picture like this, you will have some result on the here. This is for the x direction, and this is for the y directions. Okay. And one more important and very interesting here example. This is the rectangle, right? But the kernel and x direction, they just recognize this one. If you apply the Sobel filter, it just recognize this one. Why? Okay, very easy. Here, this is the kernel. This is the kernel, right? The kernel. So as I said before, the Sobel filter is the derivative. So the derivative is the intensity of the last, intensity of the next one minus the last one, right? How about the last one minus the next one? Is it the derivative? Yeah, it's also the derivative, right? This one also derivative, this is also derivative, right? So if you want to detect the another edge of the rectangle of the square here, just flip the kernel here, and this one is here, and you will have the result. Okay. So if you use the filter 2D, and you will have the result here. Okay. And one more thing I want to say here, the edge detection, right? Because if we want to use the edge detection, the edge must be 1 pixel wide, right? 1 pixel wide, right? But here, it seems not 1 pixel wide. It's maybe 10 pixel wide, right? Maybe, right? So the Sobel filter can detect the edge, but the wide of the edge is not 1 pixel wide. So it's also the how to say, the pre filter for another algorithm, like the example, the Kenny edge detection, right? In the Kenny edge detection, they will find the edge of the rectangle here in just 1 pixel wide, 1 pixel wide, 1 pixel wide. Okay, so this is for another algorithm. So I just want to mention here. Okay. Okay, and if we combine many filter algorithm, we will have another algorithm. Example here. Here we have the original one, right? Original one, and we blur the image, right? Or smooth image, right? And we subtract, and then we have another image here. We call it a detail image, right? And we apply again the original image here plus alpha detail plus this one, and we will have something like a sharpened image here, sharpened image here. Okay. So if you combine many algorithms, you will have another algorithm. Okay. So you can practice by yourself. Okay. And this one is just a summary of some important kernel for you. Right. Some important kernel for you. And here, in the previously, right, I already introduced to you how to do the filter on the just the grayscale image, right? The grayscale image. How to do it in the RGB image? How to do it in the RGB image? It's just very simple. Just split the image into RGB channel, and then do the filter on RGB channel, and then merge it again, and then merge it. So you will have the result. You will have the result. Okay. Okay. So any questions? Any questions? Okay, if you don't have any questions, we will go to the next one. The next one is very interesting. This is some kind like how to say identification, right? Recognition. Okay, this one we call this is the template matching algorithm. Template matching. So it will use the something like the cross correlation, right? As I said before, what does it mean cross correlation, right? The correlation, right? So it will find the difference between the kernel and the image, right? It will find when we apply the kernel on the image, right? It will find the different here, and the different here, right? If they are similar, the result will be very big, right? The result will be very big. But if we just apply the cross correlation, it's easy affected by the noise or especially the intensity of the light project on the image. So they propose another, we call this the normalized cross correlation. Okay, normalized cross correlation. So what the algorithm do? Okay, let's see. So the normalized cross correlation, they will use this function. Wow, very complicated function. Okay. but I will explain to you briefly and very easy way. Okay. The most easy way for doing any algorithm is do it on the example one. Okay, so I will do it on the example. Example here. This is the kernel. The kernel here, right? And then by surfing on the image. This is the image, right? By surfing on the image, right? Example is served at this position here, right? Because it's the normal line. So the result will give you the range from 0 to 1 because it is normal line, right? Normal line. So if it is similar, it will give you the number 1. So it will here 1 here. Okay, and then just serve all the image here, and then you will have this one. Okay, another here. Okay, so this is the principle working of the algorithm. Principle working. But in the reality, there are some slightly different. In the reality, the image is not clear like this. It have example some noise. Example some here, noise here, right? It be dark here or some noise here, right? Some noise here. So when you use the kernel or the template, we call it now, this is a template, right? Template, and then you apply it on the image, right? And because it's here normalized, right? But it does not give you the result 1. It just gives you the result, example 0.98, 0.99 or something like that, right? So you have to apply the something like the threshold value here. This is we call the threshold value. If the result bigger than the threshold value, you will accept it. Right? You will accept it as the image template, right? As the image template. So be careful about this one. In the real image, it's not give you 1, right? Because in the exercise I give you, it's very clear. So so they don't have this situation. Okay. So let's see. Okay, and in the Opencv, they have the function called the matching template here. The matching template here, right? What you have to do with this function, just provide the image, provide the kernel or template. They will give you the matrix result, right? And then this is the matching method, because the match template in the Opencv library, they use many methods, right? And you have to choose this one. Right? You have to choose this one because this one is our algorithm. This is our algorithm. Okay, so let's do the example. Here, I give you this picture, and this is the template. So anyone can tell me by seeing on the picture how many template can be on the picture? How many? By looking on the picture, how many position can it? Here, right? So is it here? 1, right? 1, right? Is there another? Here, right? Here, right? Is there another? Is there another? Is it here? Is it here? Okay. Yeah. Yeah. So when you apply the template on this picture, right? 3 position will give you 1. Okay. So let's see. Okay, let's see. Wait. Let me copy paste the equation for you here, and then we can do easier. Where is the equation? Yeah. Okay. Okay. Example. I have the template here, right? And then I shove on the image at this position. So what is the result of this? What is the result? Okay, so let's see. Let's do it. This one. Sigma I1 UV multiply I2 UV, right? So I1, this is the picture. I2, this is the image. So the first thing we do here, just list all the pixels on the image. Example here, 0, 1, 1, 1, A here, okay? A here. Template 1001, okay? 1001 B, okay? And then what will we do? Apply this one, right? So this one is it this one? Oh, this one is it this one? E, right? So we just do like this: 0 multiply 1, right? Plus 1 multiply 0, right? And 1, 0, and then 1, 1, okay? And then we have the result E here, E1, 1, okay? So this equation, right? We have the result E1, okay? 1. And how about the below? How about the below here? Easy, right? Easy. I1 square, right? So just square, and then plus it, right? So here, 0 square, 1 square, 1 square, and 1 square. You see, square 3. How about D? How about D? One square, 0 square, 0 square, and 1 square is the square 2, right? So the last equation is here, right? So at this position, it will give you the result 0 0.4, 0 0.4, 0 0.4. Okay, 0 0.4. Is it? Do you have any questions here? Is it anything unclear? Okay, so this is one example I do for you, right? So now, please do it for me at this position. Okay, this one will give the result here. Okay, so please do it and tell me the result. S will equal to which number divide which number? Okay, tell me. Okay, you have about 5 minutes, right? About 5 minutes, and tell me the result. Okay, so anyone tell me what is the number here? What is the number here? Anyone tell me?
Number 1.
1? No, I mean the number here.
No. Number 2.
2?
Number
Okay.
2 is number 2
And here?
over square root of 2. Square root of 2 multiplied with square root of 2.
Okay, so yeah, that's correct. Correct. Yeah. 2 and this square 2 and this square 2 and this is equal to 1. Okay. Yeah, correct. Yeah. And then just serve this one on this picture, and then you will have the result, right? And then I think this is the result. I forget to make it. And here, this is the result. Okay. And here from the picture, you can see that you will have 3 positions, right? 1, 1, and 1 here, right? 1, 1, 1. Yeah. Yeah. And then let's see the programming, right? I hope that in here we have here. Okay, yeah. Okay, another. Let's say the example. example here, right? Example, I have picture, and you see I have template, and then quiet on the picture. Okay. So we calculate it, right? Just list similar, right? Similar, right? And then you have the result here, Okay, and here you can see that just one position they have the result here. One position they have the result. Another position here is example you can see 0.9989, right? Very near one, right? So let's see what is it? What is it? So this is this position. This is this position, right? But not this, right? Not this. Right. Okay. So you can see here, right? And then we apply it by programming, and then you have the result, right? And here I will copy paste the manual and the programming for you. Okay, let's see. Okay, so it's identical. Okay, it's identical. So please pay attention. Okay, when you be careful when you do it by your hand. Okay. Okay, so this is the result. And if we want to apply the code for multiple recognition, example here, I have the template here, and I want to recognize where is it here, right? And the procedure is totally similar, Okay, here just here, right? Just here, load the image, right? And then call the matching template, right? And then to roll the result, to roll the bounding box of the result, right? To roll the bounding box of the result, just follow the procedure here. Okay. Sorry. Just follow the procedure here. Right? In the procedure, it's very easy. Just find the maximum value of the matrix, right? Find the maximum value of the matrix, and at this maximum value position, right? They will roll a line, a rectangle, and the y of the rectangle is the y of the template, is the y of template here, So after the drawing of the bounding box, you will have something like this. Here you can see. You will have the result, something like this. Okay. Yeah. So this is the matching template algorithm. So let's have a discussion on this algorithm. So with this algorithm, yeah, you can find this is some kind of like the simple recognition, right? Simple recognition, but it's have a weakness, very serious weakness. That's a example here. I change the size template like this. It cannot recognize here. It cannot recognize. Why? Because as you already know in the algorithm, right? They will serve the pixel, right? Serve the pixel, all the pixel here, surround here, right? And if it's similar, they will have the very high value, right? So if the size of the template is bigger, right? The recognition rate is reduced. The successfulness is reduced. successfulness is reduced. So in the real reality, this algorithm is very effective when the camera is fixed. Camera is fixed. If the camera is not fixed, it's dynamic or moving, changing the position, you have to take the template again. You have to take the template on the picture again, and then do the image recognition again. Okay, so this is the weakness of the algorithm. Okay, the weakness. So do you have any questions? Okay, good, good. Okay, so now please go to the e-learning. Go to the e-learning and then download the exercise and then have a look at the exercise. And then if you have any questions, you can ask me now. Because your class discussions, your class discussion time is very near of the submitting time of the exercise. So I think you can ask me now.
Dạ, thầy ơi cho em hỏi là bài 1 đó thầy.
Yeah.
Ví dụ như cái điểm anchor point nó nằm ở ô thứ tư thì khi mình apply cái kernel vô cái picture mình sẽ apply như thế nào thầy?
I think that's on this morning I already explained to you, right? On this morning, right? And I already post the movie, right? Of the result, how to calculate the exercise, right? I think that you can find the movie of this morning, right, on the discussion link, something like that. And you can watch the how to do it. I think that your friend already did very clear, right? Explain very clear on the movie. I think so. Yeah.
Dạ rồi, em cảm ơn.
Yeah. Okay. What is the exercise? Is it here? Okay. Yeah. So that means each group you will have different entry point, right? So you will have different result. Okay. And question 2 is similar. And question 3 is about the median filter. Okay. Question 4 is about Gaussian filter, right? Gaussian filter. And be careful about the sigma value, right? The sigma value will equal to this equation, right? Okay. And then question 5 is this one. This one. So each group will have a different result, okay? In the question 1, I think that's the purpose is for you to play around with the filter 2D function. Yeah, just to play around how to define the answer point. I think so. Yeah. So do you have any questions? Okay, so I think I don't know that maybe in this semester, at the end of semester, how to say how can we take the final exam, right? I have no idea about this. So I think that maybe in this semester final exam is will be how to say this will be multiple choice, maybe 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 not writing multiple choice, because previous semester at the final exam we do the multiple choice exam. So be careful about this one, okay? So if I think that in your group, all person must know, must understand how to do it, right? How to do the exercise. Not just one person, to can do 1, 2, or 3. Yeah, I think all of you have to discuss and share it, because in your final exam it will be similar, something like this, be similar. Okay, example, I can change the number here. I can change the number here, and then I have a different result. Okay, so many methods for the final exam. Okay, so if you don't have, okay, why? Yeah, correct. Yeah. If we don't do the multiple choice exam, the final exam will be similar. Will similar to your group exercise. Similar to your group exercise. But don't worry, the matrix dimension will be reduced. And just ask you to do very simple one, not complicated. So don't worry about this. Okay. No coding. Just do by hand. Just manual do. Okay, let me explain more clear about this one. Okay. Example here, right? Example, the group number 1, the answer point is at this position. Okay. The group number example, the group number 11, where is it? The answer point will be 2, right? Because 11 minus 9, right, equal to 2. So the position of answer point will be 2 for the group 11. Okay. So be careful about the answer point. Okay. Okay, so if you don't have any more questions, I think we can dismiss the class today. Okay, we can dismiss the class. Okay, thank you for your attendance today.